What if you used colour to write spells smaller? I'm the Gorilla of Destiny and I've been using my astrophysics degree to overanalyze D&D for way too long. What you're seeing here is my normal way of writing spells. And what I'm going to show you today is how we can use light and filters from astronomy to change this symbol into this one. And I'm going to tell you all in a second like what all of this means, but for now let's talk about the original. So in this system, spells are represented by 6 binary numbers, where those numbers represent the level, school, damage type, area of effect, range, and duration of the spell. And the way we write these binary numbers is for the level, we go around and if there's a 1, we draw a line between a dot and the dot next to it. And if there's a 0, we don't. When we're talking about the school, if there's a 1, we actually skipped over to 2 dots along. And then for damage type range, we're just going up in the amount of dots, and that's what I call the K value. And this means we can stack all of these binary numbers into one single rune for the spell. As some of you probably know, I've been working on arcane spectroscopy recently, which is where I take inspiration from real life spectroscopy and how we could use it on spells. Which got me thinking, what if instead of having the same coloured lines, which are all layered by skipping more dots, we instead have different coloured lines that are layered on top of each other? Now in spectroscopy, say we have a light source coming in. We put that light through what we call a diffraction grating, which means that different wavelengths of that light will go to different places. So in this case, we're going to get the red light over here and the blue light over here. There's quite a few times where you might only be interested in, let's say, the red light. So we can apply a filter that only deals with the red wavelengths, and that'll make sure the blue ones don't make it through, so we're just left with what we're interested in. Now this is where this all comes in. Instead of writing the spell down as a lot of different layered lines on this really big rune, we instead have them all be k equals 1, so that means we're drawing from one dot to the neighbouring dot, but layered at different wavelengths that I've then had to digitally turn into colour, but don't worry about that. So the spell will initially look like this, but a wizard might have some special glasses or something like that where they can see their glowing spell rune, diffract it into the different wavelengths, and then look through different filters. Which is what I'm showing down here. So these are the component wavelengths, and this is what they mean for the different stuff. And then this tells us where our filter is, basically. So as a wizard, I can move this over to where the level information is and see the binary number that I need. I can then move my filter all the way across and see all the different parts of this spell. I think this could be really cool. Can you imagine a wizard who's got a glowing spell book and a special pair of glasses? You need to be able to read it. Obviously in print this is a little bit more difficult, but I think it's quite cool. Did that make sense? I want to talk about spectroscopy more, so honestly just ask questions. Okay, bye. Have a lovely day and bye. Sorry, I've got to say that.